Welcome back to Mechanical and Electrical Things. Jerome JT62 back here with another one. In this one we're going to take a look at this Endurance Laser 10 Plus and explain how did I get this to work with Mach 3, an Ethernet Smooth Stepper, and V-Carve Pro. If it's something you're interested in, stick around. It's coming up. So let's start this off by going over some of the things you're going to need. We're going to quickly go over the different types of control boards that are available, what I'm using, and what I'm not going to talk about. The first type of board is, this is a Garble-based Arduino language, or Linux, I should say, style of board. This is a type of board that you see in 3D printers. I believe the X-Carve uses something similar to this. Shapenko, a lot of these smaller CNC routers use this style board. Like I say, in 3D printers, this is all you're going to see. Endurance Laser says that their laser is compatible with most CNC, which is true, but plug and play wise, if you are not using this style board, then you're going to have some issues. And you're going to have to maybe look at what I'm going to talk about next. The next type of controller, this is a USB UC100. This is designed to plug into your standard DB25 board. DB25 board uses a serial connection, which was a printer port, and basically all it does is it separates all the pins, the 25 pins, and each of them are a pin-to-pin input. This board came about because the connections were instantaneous, but as the printer port went away, people were stuck. So they asked, what am I to do about that? The UC100, and this is the Warp 9 Tech Design ESS Smooth Stepper, which connects with a Cat5 cable instead of USB. It does away with this cable. So if you notice here, these plug directly into this 25 pin. They plug here. For the Warp 9, you're going to use this ribbon cable and plug it in here, and then the USB is now your input. The plus side to a UC100 is that it's powered by, I believe, either the power of the 5 volts coming off of your breakout board, which you're going to have a separate power supply for. Some people use adapters. I have a little 5 amp power supply in my controller. The ESS Smooth Stepper has to have 5 volts. It has to have a power supply. So you cannot use 5 volts off of this USB for this. Let's take a look real quick at Warp 9's site here. And if you look at the Ethernet Smooth Stepper, they also have a USB, which is a USS or USB Smooth Stepper. They come in 2 different flavors. The ESS is supported before the USB. This said, and there was no plug-in, at least a while ago. I don't know if that's true now. I'm not using Mach 4, so you can go scroll through here. We're not going to go over this. But I have a 5-volt power supply in my controller, so it was a no-brainer for me to connect this. I had nothing but issues with this. There's some people that say that's not the case and they swear by them. The downside to this USB is you have to have a bulletproof system set up with no interference, or you could have some issues with this. This thing would stop on me right in the middle of something, and it just got to be to a point to where when I bought the laser and come to find out what I was going to need to hook it up, I thought I needed a smooth stepper. And this says it's a motion controller. This says it's a smooth stepper. They're both the same. They both do the same thing, different name. So this is what I'm using. This is what this tutorial, or it's not really a tutorial, it's to show you what I'm using. Everything in this video is what I had to do to get this to work. Maybe your setup could be different. Maybe your settings are different. Maybe your post-processor's different, which it is going to be because I redid mine. This is for me. So if you have issues with not being able to control this laser, there could be something in here for you. Maybe one little thing, or maybe a whole bunch of things that you're going to have to do in order to get this thing to work. I scratched my head and pulled my hair out. I'm bald now because it took a long time. Even looking at other people's videos, because their stuff didn't work for me. So a little here, a little thing here or there from every other person could help you solve some big issues. Let's move on, and we're going to talk about Windows briefly. Many people ask, what version of Windows can I use with Mach 3? And the answer is simple, all of them. All of them through 64-bit. When does 64-bit affect you in Windows 7 if you're using a serial umbilical cord printer cable? Once you step into the USS, the Ethernet smooth stepper, or UC100, which does not use that cable, you can use any version of Windows that you want. So that means you don't have to go out and buy an old antiquated computer to get this to work. I don't want a computer that's going to die next week because I don't know, because I picked it out of the bargain basement of a secondhand store. New computers these days will not come with that port. So you're going to have to buy a UC100 or an ESS smooth stepper in order to make your connections. So keep that in mind. Every single version of Windows, including Windows 10 64-bit, which I use, and that's what this is, works with Mach 3. So incidentally, I forgot to mention, this box is 3D printed. There's STLs out there. Just type in Warp 9 Tech Designs ESS. I'll post a link to where I got this. I only saw a couple, and this one works out perfect. So this does not come with an enclosure. You're going to have to figure out how you want to mount this, whether it's inside of a controller box. That's not an option for me. And then I want to be able to get to this because of the expansion ports. You can connect another 2 breakout boards to this thing. That's how it's like huge. You have like 32 inputs and outputs. It's like crazy. So that's something to think about. Forgot to say price. This is $200. UC100 is $100. And each one of them, you're going to have to get a gender changer for the UC100. I don't think it comes with one. I don't remember. Well, they may give you an option whether you want male to female or female to male or whatever. If you get the UC100, you're going to need a gender changer for your standard DB25. You're going to need a female to male to female. And for the UC100, not the UC100, I'm sorry, the ESS, it comes with 2 different lengths of ribbon cables, and it also asks you if you want a gender changer. If you have, again, this board, the female side, which is a generic like $30 board, which a lot of people may or may not have, you don't need a gender changer for this. This has 2 different lengths of cables. One is, I believe, 2 feet, and the other one's like 13 or 14 inches. Do yourself a favor and get both cables, because you may need the long one. If you get the long one, you needed the short one. You get where I'm going with that. They're only like $6 each, but the hassle of not having the right one is $100 of frustration. So get them both and order a gender changer just in case. But I thought I wanted to throw that out there. Yeah, I got to reshoot this whole section. This is why I don't like tripods. So I hope I don't forget anything. Let me close out of Mach 3 here. Initially, you're going to have to load Warp 9 Tech Designs driver. And it's done with an execution file. I'll post a link to the video from YouTube, and he shows you how to do the whole thing. Initially, what you need to do is you need to set up a profile. I don't have a hybrid machine. I can't run this on my CNC side because I have a spindle connected with an RS485, and it looks for that, and the laser doesn't cut it. So in order to create a profile, if you don't know, you're just going to say create profile, and you're going to clone it from your main machine. Mine is JJCNC. You're going to put the name. I name mine laser. You're going to hit OK. So now when you open up your loader, you're going to see your laser profile come out. You're going to hit OK. You're going to open that. And you'll notice you see the Warp 9 Tech Design come up. I gotta redo this. I don't know why that does that. But you'll see the Warp 9 Tech Design driver come up, and it loads the driver, the Ethernet driver, and connects up. Alright, so now we got a normal screen. Gonna reset that. First thing you're going to want to do after you've set this up, whether you're using the UC100 or Warp 9's Ethernet smooth stepper, you're going to have to load the .dll file into your plugins folder. If you don't know where that is, you're going to go to your drive where Windows is loaded, and you'll see a Mach 3 folder. You're going to copy and paste that .dll to the plugins folder, because you'll see it right here, ESS. It's just that simple. These are all of them that I have loaded, not necessarily using, but this is where you put them, in that folder. Head back to Mach 3 here. I'm afraid to zoom in here because that was my pitfall on the last one. So that'll be here. So hopefully you can see this. First thing you want to do is go to your configuration. And I have to tell you right now, straight off, my post processor is in inches. It is not millimeters. It's not written in millimeters. And if you put it on a millimeter machine, it's not going to work. You can change the G20 to a G21, I believe, and rename units if you want, but I have not had luck doing that. So it won't seem to convert for some reason. So this is in inches. You can find a millimeter one and maybe copy and paste what I have, short of renaming everything, and work it that way. First things, ports and pins. You're going to want to go to motor outputs, enable your spindle, leave direction and step off. Step port 1, and most people use pin 17, and I put the breakout board away again. But this is the last pin on that board. I have to use 17 regardless. You can use any pin that's not used. 17 was the only vacant pin that I have available. Anything else that I want to add would require another breakout board. So make sure that's enabled, and we're using 17 in the direction. Don't worry about it, leave it. You're going to want to put your input signal. I don't think there's anything here. Okay, no inputs. We'll go to output signals, and we're going to use output 1. Remember, because we're going to see that when we go to the spindle setup. You can use whatever output you want. You can use 1 through 6. You'll see I have 3 enabled for flood and mist, and that's for my laser crosshair. 1 was vacant, so you're going to check mark that, put port 1, pin 15. That's the only one that will work for me. I tried them all, either 15 or 10. And it's either the E stop or I can't remember. Let's see. Let's look at the outputs. So 10 is the E stop. I can use that one. Or the probe is 15. Even though it says I'm not using them, those are the only pins that work for me. None of the other ones will work. Even if I disable anything, it doesn't work. So it's either 10 or 15, one or the other. You type every pin in here if you want until you find one that works, but that's what I needed to use. So again, back to the output, pin 15. Didn't matter to me. It didn't matter whether I checked this active high or low. Still works one way or the other. But if it doesn't for you, you may want to put a check mark or uncheck it one way or the other. Just make it opposite of what you see. Your spindle setup, you're going to disable your spindle and relay. My flood and mist I'm using for my laser crosshairs. That's why this is enabled. You're going to want to enable spindle motor output and PWM control. Your base of 250 and 0, you can leave it there. You're not really using it because of the plug-in. And you hit apply. Okay. And you should probably save settings if you've made those changes so there's no issues. Now, since you've loaded the Mach, or not Mach, but the Warp 9 driver and everything in here, you're going to come up now with your Ethernet IP. That'll be set up with the video I'm going to link you to, so you know that's working. I believe he goes over this page too. You pretty much leave everything where it is. The only thing you need to touch is make sure there's output mode, and you're going to use output for 10 and 11 of 1. And make sure this dwell on both the M11 and M10 is set to 0 milliseconds for both of them. For the user DRO and the DI. Set it to 0. I don't want to hit that because then I have to restart. So you go back into plugins. The only thing you really need to change here, make sure that this PWM is checked with a base of 1,000 is good. And the biggest thing is to make sure there's nothing in the XY PWM velocity output. And make sure there's nothing in there. And then you're set with the ESS. Next thing you want to do is go back into your configuration and go to motor tuning. This made me pull my hair out for a long time till I was bald. You want to set this acceleration and this velocity up as high as you can get it. I found 16,000 steps. You can set 12,000. There's people that set 12, 13. I set mine high, 16,000, and pull these sliders up until you almost get a flat line. So that means everything's instantaneous from your velocity, and your acceleration is like instantly on. Let's see what we get with that. I'm just going to max them out. It was working where it was. I probably should have left it, but we'll just save it there. This is very important that you do this. If you don't, the spindle or your laser's not going to turn on. Or if you have this too low, your acceleration like way down here, your velocity way down, you'll notice there's going to be a delay when you go and turn the laser on. And I'll show you when, I'm not going to goof with this, but I'll show you when we get back to the laser here. Well, I shouldn't have done that. Go back and max it out. Okay. All right. Last thing, you need to go to your spindle pulleys. You need to put pulley 1, 0 to 100. 0 min, 100 max. So this means 0 power, 100% power. So anywhere in between 1, 2, 3 to 25. 25 is 25%. And a ratio of 1. This has to be done or it won't work. I believe that's it for Mach 3 in the ESS. One thing I want to point out, my post-processor is in inches. So if you're running in millimeters and you use my post-processor, you're going to have some issues with sizing, huge issues. So I've tried changing G20, G21 and renaming the processor name, changing it from millimeter to inches from other guys' stuff, and for some reason it won't work. So I just find somebody that had one that was made, actually it was Vectrix in inches, and I used that one and then modified it from there. So keep that in mind. You can even take a millimeter Vectric and use that one, and then you can pretty much post the commands, copy and paste from mine to that one, but remember, you have to change the name of that file. If you don't change the name of that file, it'll overwrite the stock post-processor and it'll be gone. I don't know how to recover that other than to reload Vectric. They may have them somewhere, but I can't find them, so keep that in mind. If you're ever going to change a Vectric post-processor and modify it, make sure you copy and paste that post-processor to another folder, to the desktop, rename it, so when you go to install it, it doesn't say that that post-processor is already there. Do you want to overwrite it? Because once you overwrite it, you've been warned. You're done. So let's turn around and we're going to look at the laser side of this. So I'm so sorry, but Mr. Shaky's back. There's too many things I need to pan around and show you, and a tripod is not going to cut it for me. So the first thing you need to keep in mind is make sure this box is turned off when you're done using this. If you don't, when you go to load Mach 3, the laser will turn on if you leave the power on. If this the TTL, I usually leave the switch on. Before Mach 3 connects with the ESS, it'll power the laser on. If you stop this because it was, you have a long time, and you want to run from here with line numbers, then make sure this is off, because you can burn your project like instant and ruin it. So always, and it's a good practice anyway, to make sure that this is powered off when you're done with the machine. So the first thing for me when I power my machine on is to turn my 5-volt enable on, turn the computer on, it loads the ESS, and I hit my 12-volt master power, and this switch here is the laser power, which turns this power supply on. This center button here, if you have a laser box, is 100%. Make sure that's always off. Always off. Again, you'll burn a hole real quick in something, or you don't want to get into that. When you turn the power on to this, okay, so take two. When you turn the power on to this, everything comes up. If I want to turn this laser on now, I don't need to use MIDI commands. All I need to do is I'm going to put 6 in here. You can hit enter to make sure it saves that. Actually, wrong window. Put 6 there, enter, and that'll be 6%. Let's see if I can't get this turned around. And you see the laser come on. It's only 6%. It's not faint, but it's there. If I turn it to, I got to be careful, 10, you'll see it get brighter. If I change it to 100, it's burning hot. 10 burns. So you need to make sure that you're away from the surface, especially if you're running anything above 6%. I don't think this will run at 5. It might. Okay, 5 I think is as low as I can go, and then it loses the signal. So 5 is the minimum that you can use. When that's blinking, you know that the spindle's on. So let's change that back to a 6. Actually, let's do a 5. Got to be careful here. I don't want to put 56 in there. Do a 5. And I'll show you when I click this how fast this comes on. It's instant. Instant on, instant off. And remember, in your motor tuning on your spindle, that's why you want to bring those sliders up, or you're going to have a huge delay. Huge delay. Also, when you restart a job, or you're done with a job, reference all home, or you better have some hard stops with proximity sensors so you don't slam this down because the machine lost its coordinates and it stops short. So I probably don't need to tell you that, but if you're new to this, keep an eye on that. Right now, if you look at the settings in here, this is, I don't know where those are from. So if I'm going to start anything, I'm going to reference all home. Next thing is air assist. I made this tube. This is another modification that I made to this. This is 5/32 brass, 1/8 that slide in each other, and I just used. You see that slides out, but this seals it, which is basic, radio control fuel tubing, just small pieces of it, and this slides out in and out and bend it over 90 almost, so that you can get that under there. You need air assist on this. I'm just telling you. It doesn't say you need it. It's an option. In my opinion, it's not an option, especially when you're running at 100%. You need it. And the 70 milliliters per hour or whatever pump that I bought, the 110 version, actually works out better than I thought. So I just use this through my cutting coolant line, just running air through there, and it's spliced in. So my first video on this laser, if you want to check that out. And this is just Tygon tubing that is used for computers. It's a 3/4 outside, 1/2 inch inner diameter, and it slides right over the top of that. So when I'm not using that, I just pull this out. And then there's little clam shell 3D printed little brackets that I designed with wing nuts on the back. So this slides up and down, and it works out really good. I'm gonna bring out some of the laser engravings that I've made. It's all the same, but I'm gonna show you some samples, and we'll talk about if this can actually cut through 5mm ply like they say. It's coming up. So here's a quick look at, these are just images pulled off of Google that were engraved. It's only done at 25-30%. Some were 25, some are 30. This is a typical example of out of focus. one of the most important things that I have to tell you about this laser, if you want it to get right and work close to what Endurance says it can do, you have to have the voltages set for the laser. And there's a video out on how to tune the DC-DC buck converter in here. You're probably going to have to do that. It's not going to be... Mine was only running at like 3.5 volts. This thing should be running at 5. No more than 5.5, 5.5. Should be running at 5, close to 6 amps. I have this set to approximately 4.9 volts at 5.5 amps. And I set that up higher this morning. This is 5mm non-laser ply. And will it cut through it? Yeah, it does. At 100%, I believe I use a G2 on this. And how many passes? It did this one, believe it or not, did it in 3 passes. You might want to set your speed up. The slower you go, the more you're going to burn. You may have to do more passes, but does it cut through and close to what they say? Yeah. I mean, I haven't tried glass or anodized aluminum because I don't have any, but I mean, you can look at that. I mean, that looks good. And I've done, that's a near and dear symbol to my heart there. 21-year Marine Corps veteran. That's my love. That's when I was first starting out, seeing what this could do. These were my initials, Jerome JT 62. This is a G8 lens at 30%. You can see how much darker it is. It's more focused, finer point. I think that's one of the better engravings. I don't think I'll be running this at 100% unless I'm cutting through something. For basically what I plan on using it for, it'll fit the bill. One thing, I haven't figured out how to do pictures with this in Vectric. I haven't figured that out. There is a plug-in that Vectric has. But again, it's for garble boards. So that's what they're supporting right now. So I'm trying to play with some post-processors and see if I can get something to work. But at this point, once I figure it out or they come up with something, then I'll post a video on pictures. One last thing, you don't want to cut on your table, especially if you're cutting through something. If you're just doing basic engraving, this is just a piece of sheet metal, 1 foot by 2 foot from Home Depot. You can see where that was cutting through. Do you want that? That's going to cut through into a wood table or a spoil board. It's going to ruin it. And not only that, but the resins and the glue and everything is blowing through there. You need to have the base of this so the air can get through it. You don't want this on a flat surface. For example, you wouldn't want to just put it on the sheet metal. It's going to fry it. And actually, this is almost too thick. I wish I could find something different. So what I may do is just actually suspend that up probably with maybe 1/4 inch pieces of something, but just even get it up higher so that air can get through there. It has to get through there. So still working on a final design for fume extraction. That's coming soon. Well, when I say soon, it seems like it's a year. I guess it was a year since I posted the last video on this. I can't believe it's been that long, but you got to buy everything. It takes time to get it. So it's just a simple thing. Nobody's sending me nothing but thank yous. So at any rate, I guess we're going to close this video out. If you have any questions concerning any of this, if you'd like the post-processor, drop it in the comments, and I usually get an email and I'll get that out to you. I may even post it on Facebook on the Endurance group. But other than that, if you leave a comment, I'll be sure you get that. I'll answer any questions as best I can concerning what I have, and possibly try to help you out and mitigate a bunch of heartache and pain that I had myself. So we'll close it. And once again, please like, comment, subscribe, questions. And once again, as always, thanks for watching.